Age 50, we've known for decades that this is particularly noticeable in men. Women are not like completely exempt, but it is, the declines show up earlier, and the declines from 50s on are much steeper in men than they are in women. In fact, actually, in general, I should have said at the outset, in almost all sensory perception, women have lower thresholds than men do, so women have better sensory perception than men. So partly from teaching this and partly from experience, I've learned that, I tell my wife, she asked me if I heard that, and I said, if it's a high frequency tone, it doesn't matter whether I heard it or not. And I've never had a very good sense of smell. I mean, I'm actually bad even compared to men in general. I'm not quite like, nose blind, but I'm not at all good. So if my wife says, do you smell that? It's like, so I just say, just take me to where it is. Just point me, I'll look around and see if I can find an explanation if you don't know. And so, when you guys shouldn't argue with women in your life about sounds, sights, smells, etc. not being there. And women shouldn't put up with it if a man tells you it's not there. We're just guys. We can't perceive this stuff. Just limit it. It was really common in text back at least up into the 80s to suggest that the male hearing loss was due to greater exposure because, men worked in industry and stuff and in noisy environments and stuff. But pretty early on, people compared across occupations and across countries and stuff, doesn't really work out. It means hearing, you get some effects from exposure, obviously, but it doesn't explain the gender difference. Even with men mostly now working in quiet environments in the U.S. and so forth, hearing still goes. One of the things I've learned from personal experience in the last few years, mentioned the top-down processing stuff earlier on. I always thought teaching about this and reading about this that you would notice that you couldn't hear stuff. What I'm finding is, especially with speech, that what happens is there are certain consonant sounds that are actually kind of high frequency tones. You lose those consonant sounds and your brain fills it in, and so it's rarely that I actually know that I'm not hearing. I hear people say odd things. And then I have to stop and think, well, that word doesn't fit in that sentence. So what sounds like that wouldn't make sense in that sentence? Or I ask people to repeat stuff again in a different way so that you could hear it. Okay. Yeah, probably enough about that. Longitudinal studies actually suggest a worse picture. Unusual things. If you review longitudinal studies, there isn't a detectable anyway overall decline in sensitivity, not confined only to high frequency, although somewhat more pronounced in high frequencies at a lot of ages. And you can actually detect it in the late 20s. It's not like a big deal yet, but you can see it starting. And certainly by the time you're 80 or so, you're starting to get pure tone changes that are actually relevant to speech perception. So you're losing more components of words yet, and overall speech perception is starting to go downhill after 80 or so. Pathological changes, about 30% of older adults are hearing impaired. So all the stuff on the previous slide, again, that was the normal stuff. On top of that, about 30% of older adults are impaired, and about half of those are legally deaf. Hearing aids sort of work for changes in the middle ear. If it's mostly bone conductance kinds of issues, cranking up the volume does help, sort of. We'll get to some examples of that in a minute too. But totally blows out directionality, and it magnifies everything in the environment. And hearing in group settings is difficult for people. You can't always tell who's talking. If more than one person's talking at a time, it's even harder to distinguish the two voices than it is without a hearing aid. And then hearing aid satisfaction starts declining about 60 and later, and gets worse with each decade as you go up into the 80s, probably because the changes are moving in and out of the periphery into the neurological system. Now the better news here is that they are developing digital hearing aids that can kind of bypass all of that and plug into the auditory nerve. And I don't know how long it'll take, but it's probably not out of the question that you'll eventually get stuff that will be able to bypass a lot of the auditory nerve itself and get you at least close to auditory cortex and kind of work around the neurological. Some of these things are actually available on the market now, which are expensive so far. Maybe they'll come down with price.
So you want
Go ahead.
I'm sorry, you said you want the hearing aids to bypass the auditory nerve? Or?
At least some, well, what they can do now is plug into it, so you can bypass like the middle ear and even the inner ear stuff. And in principle, you should be able to plug in increasingly brainward from, as you go up the auditory nerve from the cochlea. So you should be able to get like closer and closer to the brain. There are biomedical engineers who would argue that at least eventually you'll be able to plug directly into the auditory cortex.
So the cochlear implants, they're not, what are they connected to?
I think they mostly bypass, but I'm not 100% sure. I think you can kind of get like, you already kind of replace it in some cases. The cool thing too about digital hearing aids is that to some extent you can get them so that they filter out noise selectively, and some of them I think can even be set to be somewhat directional. That it gets as good as the actual brain and functioning ears, but you can do a lot more with the software to like average out sort of random noise you can screen out. You can set up for different frequency levels, and to some extent you can. I think what they do is actually sort of like selectively magnify sounds that are coming from in front of you as opposed to behind you. So you can get even that level of screening of even speech. So it could be kind of cool. People are working on the vision stuff, but so far it doesn't look all that impressive. I mean, you can see like light and dark and like really large pixels. But it's better than not being able to see at all. Probably it'll get better. Sort of gyro robotics. There is a guy across the street too, the biomedical engineer, who's trying to work on like memory implants, working on rats and stuff. Sort of mixed up. He tells this is all through the. There's a branch of the Defense Department called DARPA that funds like military technology research applications. And they sort of do like all the science fiction kind of research that's done in these areas, and so he gets all his funding from DARPA. And he's at least got DARPA convinced that he's eventually going to develop a digital hippocampus. To be able to compensate for Alzheimer's. I'm not holding my breath. I mean, it may happen, but I don't think it's going to help. But who knows? Some of this stuff happens really fast. And I had a long time career of being wrong about it. So, probably both because of differences, both because of auditory perception